this also, if it is fine. So Rasuguru, tell the questions. Let's see. It will be fun for us to try to solve it. Maybe start with
Yeah, so I have
some
to
easier
find the
ones.
question.
Oh, okay, okay. So find it then.
Decide if any of the following is true. The question is to decide if any of the following is true. Like if it is like two statements are given, if it is true, then prove it, or if it is false, then give it counter example.
Okay, so this is your mid-sem paper.
Yeah.
Okay, linear algebra. Okay, true, false. Let's see. Let's do it. Yeah. Okay.
Yeah. So A and B are both n cross n matrices.
Okay, A and B are n by n matrices.
Yeah. X and Y are column vectors, n cross 1.
X and Y are n cross 1 column vectors.
Yeah. Over field depth, everything is over field depth.
Okay, okay. So let's just say over R. Okay, for the time being. Okay.
So first statement is X transpose A into X.
X transpose, I'm writing like this, into A into X
equals to X transpose B into X. For all X belongs to F to the R to the power n.
For all X in R to the power n.
Yeah, so this is the like this is given. So does this imply that A equals to B?
Does this imply that? Okay.
Yeah, and statement 2 is X transpose into A into Y equals to X transpose into B into Y. For all X comma Y belongs to F to the power n, R to the power n. So does this imply equals to B?
Okay. Yeah. So I'm seeing this question for the first time. Adish is also seeing it for the first time. So Rasubro, you have to, whatever, if you know the solution, then you should tell us how to do this.
How to do this is, first I thought that if statement 1 is true, then statement 2 must also be true.
Yes, Adish. Anything?
Yeah, just let me clear some terminologies.
Yes, yes.
Then
Yeah. Yeah.
Can you define a transpose? I forgot that.
Yes, Rasubro will do. So you will answer all the questions. Yeah, Rasubro. So what is transpose?
So a row is get exchanged to, like gets to a column, like Aij becomes Aji.
Yes. Okay. Like it will become like this, and this is the kind of thing this is.
Okay, so first statement is false.
Will make it like from a column matrix, it will become a row matrix, right?
Yes.
Yeah, yeah.
And you can see then that these are all numbers. Actually.
Yeah, that's the thing.
Rasuro, can you say why these are numbers?
Like just multiply, and then we can see that these are numbers.
Right. So it's 1 cross n and dimension
1 cross n cross n cross n cross n cross 1. So the total dimension is 1 cross 1.
1 cross. These are all numbers.
Yeah. So basically, the multiplication of the first two will yield you a matrix of 1 cross n, right?
Yes.
The 1
Yes.
cross n. So 1 cross n into a matrix of n cross 1 will yield you of 1 cross 1, and 1 cross
Yes.
1 is a number. Okay,
That's
now I
right.
got it.
Yeah. That's okay.
But then I feel that this is just like a exercise of what can we say, multiplication. But what is like the actual physical, like the deep meaning of the
I
statement?
don't know
Right?
that.
That is the
Let first solve the question. Yeah, let's see what Rasubro will tell us the solution. Then we can think if there is.
Shall I tell the solution?
Yes. Maybe gradually you can tell us. Yeah.
So X transpose into A into X is a 1 cross 1 matrix,
Hmm.
and we know that in every 1 cross 1 matrix is a symmetric matrix.
Right.
So take X transpose into A into X whole transpose.
Mm-hmm.
That becomes X transpose into A transpose into X.
So you're investigating statement 1.
Yeah.
Okay.
Take whole transpose. So this becomes X transpose into A into no X transpose. Don't do that X transpose into B into X. Like I am just saying, X transpose into A into X whole transpose equals to that is X transpose into A transpose into X.
Right. Right. Okay.
Now take B equals to A transpose. So I am giving a counter example.
Yes. Yes. Right. Yes. And you are saying that this is you've already said that this is equal to this.
This is equals to yeah.
Right.
X transpose into A into X equals to X transpose into A transpose into X for all.
And so you're saying A transpose also works in place of B.
Yeah. But A is equals to A transpose. That's not possible always.
Good. Right. So A equal to B transpose also works. I mean, B equal to A transpose also gives us. Good. So that's a very smart solution. All right. I would have not thought of it maybe. This. Good. Now, Rasubra, tell us. So the first one is false. So you'll be telling us the solution, and we'll cross question you. So this is false. Second one.
Second one, I tried to prove it true because it was of more marks. So I thought it must be true.
Like if A equals A transpose, then like the element Aij must equal to the element Aji, right?
Right.
Yeah. But that is not true.
That's not always
That is
true.
yeah.
That's a good one. Yeah. Okay.
And
So
can
what
you
about?
just state the result about the symmetric thing again?
Yes. No. So nothing. He just said that because it's a number, so it is a symmetric thing.
Right. It's only one entry, right?
Yeah.
Mm-hmm.
So,
Yeah. Okay.
And therefore, its transpose will be itself.
Itself, right? Okay.
Yes.
Mm-hmm.
But see, Adish, if you are doing this question, you can just take like a 2x2 example and get a counter example also. This is a smart solution. I agree. But you can just take a 2x2 counter example also. Just take a 2x2 matrix and calculate, and then you will know, right? So what I would have done maybe if I did not know any theory, let's assume for example for a minute, I would have done like this. Just write, and then just write x1, x2 here, x1, x2. Okay, and then when you expand this, then you would know what's going on. Okay, I'll not do it right now because then we'll not finish the paper. Then you expand this, you'll see how the expression looks. And you will see that in that expression, A12 and 21's rows can be swapped. Okay, you would just see for yourself when you take, or even further, you can just take some entries here actually. Okay, and then you would know to what other example to take. Yeah, so it's just becomes a symmetric polynomial in two variables. It's not a profound question. Okay, you have to just do it for small cases first. Okay. Let's do the second one and we can see. And we will try to find the geometric significance to this maybe also. Let's do the second one.
So for the second one, I thought it to be true and then I tried to prove it. So I have to prove that the ijth entry of A is equals to the ijth entry of B.
Okay, so enough to show, or rather equivalent to show that ij entry. So I'll just write this is aij. Okay.
Yeah. So now I wanted to choose X and Y such that I get the ijth entry like of both A and B. So I wanted to choose X and Y in that way. So let's start. Let's write A equals to A11, A22, and
Okay. Yeah, so I won't be writing B. I'll only write A, and you should explain us only using A. Okay.
yeah, A11, A12.
Okay.
So I wanted to get the ijth term using X and Y. So choose X to be let's say I want to get A11. So choose X to be X transpose to be 1000, that row vector.
Okay. So E1.
So what this does is it just takes the top column out and rest all is 0. Like it just takes the top column out, A11, A12, A1.
Top row.
Top row, sorry.
Right. So this is just R1.
Yeah.
Okay. Good.
Now choose Y to be 1000, like column vector 1000.
In general, if I want ijth entry, would you want to?
So that to be EI and this to be EJ transpose.
Right. So you're saying that when you take EI, then the ith row is picked by this multiplication.
Yeah. And from that ith row, we pick the jth column by EJ transpose, multiplying right hand side by EJ transpose.
Right. Yeah, Adish, if you something is interrupt us, okay? Yeah.
No, I am getting it. Like this is a very clever idea.
Yes,
It's like you're searching for that thing.
Yeah, you're putting the value and you're getting that thing, right? See, all these small things are going to be extremely useful later on. If you look at Hoffman and Kunz or any book, you will see chapter on bilinear forms. This is basically bilinear forms, but I'm not using that word and so on. All this will be used to prove the cornerstone theorems in bilinear form theory and inner product theory. There are 3-4 chapters devoted to that. Maybe that will not be done in first course in linear algebra, but these are like the building blocks to that. These are the tricks for that theory. But anyways, we'll just seeing it on like this only now. And then it's understood. Good. So far, so good. So let us keep this page. I'll not erase this. Move to the next page. If we get time in the end, then we will discuss some more meaning behind these questions. Otherwise, we will not. Okay. But for now, then later on, we will see. Okay. Let's do some other next question.
So next question is, suppose x1, x2, x3 is a basis of R cube.
X1, X2. Okay, X. So maybe I'll write it like this: X1, is a basis
of
for
R cube.
R3. Okay, can you just define basis for us? Just quickly.
So a
Just
maximal linearly independent set.
okay, in a more simpler
Like
way.
it spans R cube and it's also linearly. It spans R cube and it's also linearly independent. X1, X2.
Right. So all you are saying is that given anything in R cube, you can write it as a combination of these three. Right. So like if it's given 1, 2, 3, then you can find some C1. The linearly independent thing is not necessary here because there are 3 vectors only. So you cannot do it 2. That should be clear. You can do it with, you can find C1, C2, 3, and you can do that for any vector. So it's a okay. Then
Show that for a sufficiently large real positive alpha.
so that for alpha large enough,
x1 comma
Mhm.
x2 plus alpha 1 x2 plus alpha x1
x1 comma x2 plus
alpha x1
uh-huh,
and x3 plus alpha x1 is
Mhm.
also a basis in which all coordinates are positive. Coordinates of all the vectors are positive, like x1, x10,
yeah,
x.
in which all coordinates
Of all the vectors are positive. And it's given that x1 has all coordinates positive.
that's what I was thinking. Yeah, that how will this happen? Yes, and x1 has all coordinates. So let us do it like this. Okay, let me just write it. So I'll do one thing. I'll just write the matrix. Okay, where the coordinates of x1 will be in the first row. I'll write it using x only. x11, x12. So this is the first. This is x1, the coordinates, because the question is about coordinates. So let's write it coordinates only, and then x12. No, you may or may not use the matrix, but these are just the.
So here the first row is like the coordinates of x1, right?
Yes.
Second row for x2 and third row for x3.
Yes, it's just like stored in one place.
Given that,
That's
yeah, and it's given that x11, x12, and x13 are belonging to R plus.
yes.
Hmm.
Yes, yeah. The first 3 at the first row is positive. Yeah, this is positive. Yes. So then, Rasubro, how do we do this?
Yeah, so like I did the argument like x21 plus alpha into x11. This must be greater than 0.
x21
x2 plus alpha into x11.
x21 plus okay, yeah, alpha into x11.
This must be greater than 0.
Yes, because we want all the coordinates to be greater than 0, right? Okay.
I
Yeah.
guess x31 plus alpha x11 should be greater than 0.
x22 plus alpha x12, that's also greater than 0.
Right, and that also you can write it in this order or
So
like
there will be
Adish.
6.
Yes. Yeah, we have to write all the okay and so on, and maybe
So
same thing.
take the maximum of minus x11 by x21, x11 by x22.
Yes. So I mean, I will assume that there is an alpha such that all are positive. There is this alpha such that this happens.
Yeah.
Good.
We
Is that
get such
okay?
an alpha.
Yeah, that is we understand that can be done.
Now we just have to prove that this thing will be a basis, right?
Yes, that is a challenge. So why will it be a basis?
So it already has three vectors, x1, x2 plus alpha x1 and x3 plus alpha x1. Now, if we can prove that these three are linearly independent, then we are done. Maximal linearly.
Okay, so just a minute. Yeah. So that is correct. So the question comes down to just saying that if this is a basis, then this is also a basis.
Yeah.
For in fact, for any alpha. Here, positive, negative doesn't matter. Am I right? Or
Yeah.
right? So
Yeah.
just prove that then for us. If this is a basis and this is also a basis, maybe without linearly independent, can you just
No.
do
Like,
it?
can you just state in one line like what is linearly independent? Like I have studied that, but right now I'm not able to recall it. So clearly.
Yes, no, that is right. We will say that, but yeah. So that basically just means that no linear combination is zero. So C1x1
Okay, I got it.
is not. But I will want Rastupro you to not use linearly independent and do the problem. Can you still do it? Can you just show that this spans R3? Just as simply as it can be done.
Yeah. So in the exam, I did like it spans actually. But I did not do linearly.
Because we don't need to, yeah, because the dimension formula, but means dimension is 3. But anyway, just prove that it spans R3.
Yeah. So you can do that like span of x1, x2, x3 is R cube. So beta 1 x1 plus beta 2 x2 plus beta 3 x3, that spans R cube. Like that set overall beta 1, beta 2, beta 3
Okay.
equals to R cube.
So let me write that. This. Okay, this you are saying is actually R cube, right?
Yeah.
Okay.
So now we want to see like some gamma 1 x1 plus gamma 2 x2 plus alpha x1 plus gamma 3 x3 plus alpha x1, this set.
Hmm. Yes. Okay. Go on.
Plus gamma 3 x3 plus alpha x1. Now just write this in that form, like gamma.
I think I can see what he is trying to do.
Right. So it's not difficult. Okay. But still, Rasubro, can you complete?
So take gamma 2 equals to beta 2, gamma 3 equals to beta 3, and beta 1, gamma 1 plus alpha gamma 2 plus alpha gamma 3 to be beta 1. Like you can always do that.
Yeah, but then you have to just show that you can find such gamma 1, gamma 2, and gamma 3.
Yeah, so
But that depends
always
upon
you can
alpha.
Yes, you can solve it. Right. It's easy. I agree.
Because because the choice of alpha is in our hand. We just have like a minimum condition. If we satisfy that, then it is in our hands, right?
Oh,
The
no,
choice of
no,
alpha.
that's right. But what I want to do is I want to show that regardless of whatever alpha is, you have to prove it. Right. Like for alpha equal to 0, the problem is trivial. It is the same question as the question, as what's given. but I'm saying that for any alpha it is true. Okay, so you can just say that for any alpha I can find gamma 1, gamma 1, gamma 2, gamma 3. Okay, like fixed alpha. So not to change the alpha. Obviously in this question you can change the alpha. If you're increasing it, then it's not a problem. But see, a more simpler way maybe would be to just show that using these three you can get these three.
Yeah.
That is much simpler. Well, everything is simple, but that is much simpler in this. So what you just say is that you take this time minus alpha times this, then you get x2, and similarly you can get x3. So if you can generate a generating set, then you can generate the whole space, and that is the crux here, right? Okay, so don't means not to prove the whole that it generates the whole space, but that just that it can generate this. Okay, that is the
So this set is spanning the spanning set.
yes. And so obviously, yeah. So it's like we are not. So point is that we are doing in this way. What we are doing is we are doing only what the problem asks and not more. What I'm trying to say is that let's say in this solution, we are actually in this solution we are actually finding the beta 1, beta 2, and sort of we are actually finding the gamma 1, gamma 2, gamma 3 more explicitly, right? But that question is not asking that, right? That's the point. Okay, so that's, and here in this solution you just do what is asked and not more. Okay, you just show that you get x2, x3, and then they generate, you just use that fact without the exact ways in which they generate or whatever. So that is the extra work which this solution might be doing, but yeah. And if you just go do this, then that's not needed. Okay. Okay, so again here there are many interesting things to see, but we will not do it now. We'll move to the next question.
Yeah.
Maybe
So same
later.
question, part B.
Oh, okay. Right. Part B.
So part B was
Oh dear.
suppose A and B are two M cross N matrices.
A and B are M cross N matrices. Okay.
Over a field F or RC. So we have to show that if rank of A plus B equals to rank A plus rank B,
Mm-hmm.
rank A plus rank B, then rank of A intersection rank of B is equals to 0.
Rank of A intersection rank of B.
There should be some 0 1 cross N matrix. Like
Okay. So okay. So rank of A